let's look at a couple of examples on how we can solve radical equations. I've made a couple notes above that we should state the restrictions on the variable, solve the equation, and then we should also verify the solution. When I look right here, I know that in order for this expression to actually exist, the 2x must be greater than or equal to 0 in order for the radicand to be a positive number. So I'm just going to divide by 2. So in dividing by 2, I know that my restriction on the variable here is x must be greater than or equal to 0, where x belongs to all real numbers. Now, the next thing I want to look at is how would I go about solving the equation? So when I look at it, my radical is isolated. There's only one thing on this side of the equal sign, a positive number on this side. To undo a radical or a square root, I'm going to square both sides. So when I square both sides, squaring a radical, of course we know that the square root means the same thing as an expression to the power of a half. So a half times 2 gives me the expression which is inside. 8 squared is 64. When I divide by 2, I get an answer, x equals 32. Now, an important part of solving radical equations is actually to verify the solution, to make sure that no extraneous solution was gained. So I'm going to go back here and I'm going to verify by substituting it into my original equation. So I'm going to see if the square root of 2 times 32 is equal to 8. And in this situation, I can very easily see that the square root of 64 is equal to 8. So my solution has been verified. This is a true solution. Let's look at another example. When I look at this example, I have something added to the radical expression. So the very first thing I need to do is I need to isolate the radical. Okay, first I'm going to state my restrictions. I know that 2x plus 1 must be greater than or equal to 0 in order for the expression to be defined. So this means 2x must be greater than or equal to negative 1. I will divide by 2 and I get x greater than or equal to negative a half, where x belongs to real numbers. Now the first thing I'm going to do is I'm going to subtract 3 from both sides. So in subtracting 3 from both sides, I've isolated the radical. So this gives me 4. To get rid of the root sign, I'm going to square both sides. So this leaves me with the expression 2x plus 1 equals 16. This means that 2x equals 16. Take away 1, which is 15, and I get a solution of 15 over 2. Now, 15 over 2, of course, is 7.5. So because this is an exact value, you can rewrite it as a decimal if you would like. Now, to verify my solution, I'm going to go back to my original equation, and I'm going to say 3 plus 2 times 7.5 plus 1. I'm checking to see, is this equal to 7? And of course, when I multiply these together, I get 15 plus 1, which is 16. And I know that the square root of 16 is 4. So 3 plus 4 certainly equals 7. This is a true solution.